Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at part 1 of a 3-part series of trigonometric functions for mathematics grade 10, and that is the sine graph. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 and part 3 of this 3-part video series. Also, if you have any questions or would like to make video requests, please comment down below with the topic you would like me to cover and the grade, or simply send the information to the contact details provided in the description box. Also, don't forget to like this video and share it with all your friends on all social media platforms. Now back to the video. We're going to look at in detail functions of the form y equals to sine theta, which is the most basic sine graph, and functions of the form y equals to a sine theta plus q, and we're going to look at the effects of a and q on the function on the graph. Number 3, we're going to discover characteristics, meaning the domain, range, period, amplitude, intercepts, and turning points of all types of sine graphs. And number 4, we're going to look at examples that help you demonstrate the knowledge that you learn when you need to answer questions. We have a lot to cover, so let's start. Functions of the form y equals to sine theta. As I said, this is the most basic function of a sine graph. Now, a lot of people struggle with functions because they don't understand the basics. Tables help you figure out what the shape of a function looks like, and we're going to use those tables in this case to plot the graph of y equals to sine theta. Like I said, the most basic. This has a domain of between 0 and 360 degrees, meaning that these are all the x values allowed in this function, and also it has a maximum height of 1 and a minimum height of -1. You're going to see that as we plot the graph, but basically it has an amplitude of 1 and a period of 360 degrees. We're going to discuss all these characteristics I'm mentioning in a few minutes. Now let's plot this graph. What you do is you have two rows. The first row is the row of thetas, and the second row is the row of the function sine theta, or what you get when you punch that into the calculator. Now what you do is you go into your calculator and you punch sine of 0. It will give you 0. Now make sure that you have your calculator in DEG or degrees, not gradients or radians. Now, with those two, you're going to get a correct answer, but in the wrong setting. We're not looking at gradients and radians in this time. We're looking at degrees. So make sure that your calculator is in degrees so that you get the correct answer for this one. Now, for those that use a Casio, sometimes you might find some of the answers are presented to you in surd form. That's okay. All you need to do to change from surd form into the decimal format, which is this format, what you need to do is press the S to D button. It will give you the answers in decimal format. Now, when you go to sine of 60 degrees, it will give you, in a Casio calculator, square root of 3/2. That is the correct answer. There's nothing wrong with that. Now, in order to change that, just press the S to D button. Now, your answer for sine of 60 will give you 0,866 and so on and so forth. Now, what we did here is we rounded that off corrected to decimal numbers. Now, if you need help with rounding off, there's a video I did. It's on the channel. It's published. The video title is called The Number System. That's where I look at how to round off numbers in between. Now, you complete this table, and this is what the table will look like. So what you do is now you plot this on a Cartesian plane. You have your y axis and your x-axis, or your theta axis. Doesn't really make a difference as long as you understand what you're talking about. Now we'll plot the graph. At 0 degrees, your sine is 0. So we go on the graph, we go 0, 0. It will be right there at the origin. 30 degrees, half. Your half is over here. Here is your half, 0,5. So for 30 degrees, that's where you put the dot. And then you continue with the rest. Okay, let me fix that. You continue with the rest. For 60 degrees, that's 0,87. For 90, it's 1. For 120, this and this, all of this. Now I'm going to plot this quickly. 0,87 right over there, and then at 90 degrees it's 1. It goes back to 0,8, then down to 0,5 with 150, and then 0 at 180 degrees. At 210 it goes to negative half. This is where negative half is. 240, that's negative 0,87. There is the, okay, and then you reach negative 1 at 270, goes back to negative 0,8, negative half, and then back to 0. And now we join the points. Okay. Let's join the points better. And that's what your graph should look like. It has a minimum here at negative 1 and 270, a maximum at 90 degrees and 1, 0 at the origin, 0 again at 180 degrees, 0 at the 360 degrees. And that is the graph of y equals to sine theta. Now I drew this in a graph calculator so it can come out really nicely. Here are all the peaks mentioned, key points. These are your x-intercepts, your y-intercept there. So the x-intercepts are at 0, 180, and 360. Your y-intercept, where the graph cuts the y-axis, it's at the origin 0, 0. Your range goes from negative 1, that's the lowest y value, and the maximum value is 1. So the range goes between negative 1 and 1. Now the maximum turning point is at 90 degrees 1. There. The minimum turning point is at 270 degrees, negative 1. And the amplitude is the maximum y value from the position of rest, which is the x-axis in this case, to either the highest point or the lowest point on the graph, and that is equal to what? That is the amplitude. These are the characteristics of the graph y equals to sine theta. Now let's look at a more general type of question, functions of the form y equals to a sine theta plus q. And let's look at what the effect of q is on the graph. Notice, remember that we started with the basic one, y equals to sine theta, and this is the red graph. It goes from 0, peaks at 1, goes back to 0 at 180, goes to a minimum at negative 1, 270, negative 1, and goes back to 0 at 360 degrees with the amplitude of 1. There. That's your basic graph. Now, what happens when your Q is 1? You get the blue graph. In other words, your graph is simply shifted 1 unit up. Let's look at the characteristics. Instead of the y-intercept being at the origin, it goes 1 up. So that is 0 degrees and 1. That is the point. Your maximum, instead of being at 90 degrees and 1, it's still at 90 degrees. It hasn't shifted on the theta axis or the x-axis, but it has shifted on the y-axis. It goes up to 2, which is 1 unit from the original maximum for y equals to sine theta. And now your intercepts change on this blue graph. Now you only have one intercept at 270 degrees. That is your minimum. Notice that your minimum was shifted from negative 1 in terms of y to 0 because it was shifted up. That's what happens. What happens when your graph, your q is equals to 3? Same story. You're shifting this original graph of y equals to sine theta 3 units up. So the y-intercept will start at 3 instead of just 0. And everything else is pushed 3 units up. Your minimums, your maximums, everything is pushed 3 units up. What happens when your Q is -1? Everything is pushed 1 unit down. There is the green graph. Pushed 1 unit down, and then -2 for Q pushes this original red graph, y equals to sine theta, 2 units down. Notice that your y-intercept is -2, 0 degrees, -2. There. That is the effect of Q. In general, if your Q is positive, it shifts your graph Q units up. If your Q is negative, the graph, the original graph is shifted Q units down. Positive Q up, negative Q down. That's the effect of Q. Now let's look at the effect of A on the graph. Let's start from the original, y equals to sine theta. In this case, our A is equals to 1. Got your normal graph, right? What happens when your A is 2? In other words, y equals to 2 times sine theta. You still have your origin or start at 0, but look at what your peak or your maximum point is at. It's 90 degrees, still same degrees on the theta axis or the x-axis, but your y value is 2 there. In other words, your maximum point is at 90 degrees 2 because of the 2 in front of your sine theta, which represents A. Or the amplitude, the highest the distance from the point of rest to the maximum value is 2. That is the amplitude. So A affects your amplitude. Notice that your minimum value is now at 270 -2. What happens when your y equals to half? Same thing. Your amplitude is half, because from the point of rest to your maximum value, right, that is half. Minimum is net -half. What happens when your A is -1? Good question. You get the blue graph, and basically your original red graph is just flipped upside down along the x-axis. So instead of a peak here, you get a minimum turning point at -1. That's what it starts with. It goes this way. And then you get your maximum turning point at 271. Y equals to negative sine theta. -3 sine theta. Your graph is flipped upside down and your amplitude is 3. Start with a minimum value, minimum turning point of 90 degrees, -3, maximum turning point at 270 degrees and 3. So basically the effect of A on your graph, if A is positive, it just increases your amplitude, but your graph still looks like the normal y equals to sine theta, just with a different amplitude. When your A is negative, on the other hand, it is flipped upside down and the amplitude still applies. For example, the amplitude for y equals to -3 sine theta is still 3. Why? Because the amplitude of a graph basically is represented by this. It's the absolute value. That's the amplitude. Amplitude is the absolute value of A. So the absolute value of -3 is +3. That's what the absolute value addresses. It makes any number, whether positive or negative, equals to positive. Why? Because we are looking at the size, not necessarily the direction. The -3 tells you the direction, but the absolute value, which is the amplitude, will tell you the magnitude or size of the stretch. Now let's look at in general the characteristics of the graph y equals to a sine theta plus q. Your domain will go from 0 to 360 degrees. Now until you get to grade 11 and grade 12, this is the domain we deal with in grade 10. And your range will be from negative a plus q, if your a is positive, meaning that your graph goes from the maximum turning point at 90 to a minimum turning point at 270. It is positive. Your a is positive. Your graph shape will be normal, looking up like this. But if your a is negative, it will look like this. It will start with a minimum turning point and end with a maximum turning point. If your a has a positive sign in front of it, then your range will be minus a plus q on the left hand side, the minimum point, and the maximum point will be a plus q. Don't worry about this. We're going to demonstrate it using questions and example. If your a is negative, meaning that your shape starts with a minimum and then ends with a maximum point, then your range will go from whatever that a is with its negative sign plus q, meaning the shift up and down. Then on the maximum end, it will be negative a plus q. The period has not changed, does not change. Like I said, we deal with a domain between 0 and 360 degrees and a period of 360 only for grade 10. Beyond grade 10, that's when you're going to start looking at different types of periods and different types of domains and all that. Now, the amplitude is simply the absolute value of A. Remember, whether the amplitude, whether the A in front of your sign is negative or positive, the absolute value of that will give you a positive number, because the amplitude is simply the size, not necessarily the direction. Intercepts, your y-intercept will be at 0 degrees and q. Now, depending on your q, that's what your y-intercept is going to be. For example, with y equals to sine theta plus 3, the y-intercept was at 3. Y equals to sine theta minus 2, the y-intercept was negative 2. Remember, q affects the y-intercept. And then the x-intercept will simply be at 0 degrees, 180 degrees, and 360 degrees. That's where your graph for this grade 10 cuts the x-axis always, or the theta axis. 0 degrees, 180 degrees, and 360 degrees. That's where your x-intercepts are. Now we're done with the characteristics. Let's look at some examples. Now in this one, we're given the following graphs. Identify a function that matches each of the following equations. Okay, you can see this is a normal graph of a sine graph, so that is y equals to a sine theta plus q in general. All right, so let's look at f of x. It peaks at 3 and has a minimum turning point at negative 3, 270. So it's a normal sine graph. All right, your a is positive in all of this because none of them start like this, looking down with a minimum turning point. So now let's look at the options. We've got a equals to y equals to sine theta, b y equals to half sine theta, c y equals to 3 sine theta, and d equals to 2 sine theta. Now let's match them. F of x has a peak at 90 degrees and 3, trough at 270 degrees and negative 3. So definitely that is y equals to 3 sine theta. So that is f of x. Let's match them up. This one is f of x. All right, next one. G of x peaks at 90 degrees 2 and has a minimum point at 270 degrees and negative 2. Okay, that will be y equals to 2 sine theta. That is our g of x. G of x. Next, h of x peaks at 90 degrees 1 and has a minimum turning point at 270 degrees negative 1. That's your normal y equals to sine theta, and that is number A. So our h of x is represented by number A. H of x is represented by number A. And the last one, the K of X, the green graph, peaks at 90 degrees and half, which is half of 1, has a minimum turning point at 270 degrees and negative a half. So yes, it is y equals to half sine theta, and that's how you match these graphs. So that is K of X. Next question. The graph below shows functions f of x and g of x. Now you've given f of x is the black graph. We're given the equation for that. It's negative 4 sine theta, which makes sense because it starts with a trough or a minimum turning point, and the trough is at 90 degrees negative 4 and has a maximum turning point at 270 and 4, and your amplitude is 4, which is the distance between the point of rest and the maximum turning point or the minimum turning point. The size is 4 or the length is 4, so that makes sense. Now this one is simply flipped upside down of this. It's a flip upside down of the original graph, so that means this one will have a positive 4 sine theta. So therefore g of x is simply equals to, g of x, okay, let me fix this. G of x is equals to 4 sine theta. Easy peasy. Next question. Give the equation of the following graph. Okay, what to do with situations like this is you create a resting point, that line of rest, by connecting the beginning of point of the graph to the ending point of the graph like this. And now it will give you the size or the length from the point of rest to the maximum point, or the point of rest to the minimum point. Now that is from 1 to 2. That is 1 unit. That is 1 unit long from this point to this point, the maximum point. That is 1 unit. So that is 1 unit. Let's note that. That is 1 unit. That is 1 unit. All right. So meaning that you have an amplitude of 1. So meaning that your A is equal to 1. All right. Now, but notice that your graph, instead of having this resting point at x, it has the resting point at 1, meaning that your y-intercept now is at 0 degrees and y. That means this graph is shifted 1 unit up. Okay, so it's shifted 1 unit up, shift 1 unit up. All right. Meaning that your Q, therefore Q equals to 1 plus 1. So your Y equals to, remember the general equation for the graph is A sine theta plus Q. Your A is 1 and your Q is 1. Therefore, the equation Y equals to sine theta plus 1. That's how you answer that question. Next question. For which values of theta is the function negative in the interval? So when is a function negative? When that piece lies below the x-axis. It is positive when that piece lies above the x-axis. Negative when it lies below the x-axis. Now the part that lies below the x-axis is this bit until that point, and that bit until that point. That is negative. The part of the function that is positive, meaning lying above the x-axis, is this bit from between 210 to 330 degrees. So to answer this question, for which values of theta is the function negative? Now, that is between 0 degrees and 210. All right. So for that is theta. That is for theta, which lies between 210 degrees on the right hand side and 0 degrees on the left hand side. And also this bit, this part between 330 degrees and 360 degrees. Okay, and between, for theta is between 330 degrees and 360 degrees. And that's how you answer that question. Next. Shown the following graph of the following form: y equals to a sine theta plus q, where point A, this point, is at 270 degrees and -6. Okay, let's label that 270 degrees and -6. 270 degrees and -6. That is the point. Okay, let me fix that. 270 degrees and -6. Okay, the other point they say is, and point B, this point which is 90 degrees and 2, 90 degrees and 90 degrees, and the y coordinate is 2, 90 degrees 2. Determine the values of A and Q. As you can see, we've got two values. There are two unknowns that we need to solve. So you've got two unknowns. So this is the situation we have. We have two unknowns, all right, that we need to solve. And the unknowns are A and Q. So we will need two equations to solve this. And we've got all the information we need to form those equations. We've got your general form, which is y equals to sine theta plus q. Now, if you need, obviously, we're going to use the method of solving simultaneous equations. If you need help with simultaneous equations, I've got a video on the channel. Please go watch it for linear equations and for other equations, including linear and quadratic equations. For grade 10, we've got one for linear equations. Please go watch it. And so you start by writing down the general form of the equation. Y equals to, that's y equals to A sine theta plus q. That is the general form. Now we've got 2 points that lie on the equation. The first one is 90 degrees and 2. Okay, point 90 degrees 2 lies on graph, lies on y, all right? Therefore, you substitute them. For y, you replace that with 2, then A sine, the degrees is 90 degrees plus q. All right, therefore, 2 equals to A. Now you calculate what is sine of 90 degrees. Take out a calculator. Sine of 90 degrees, that is equals to 1. So that will be 1. Let me use some color to demonstrate. So that will be 1 plus q. Now therefore 2 equals to A times 1, that is A, plus Q. That is your equation 1. Now for equation 2, the other point, that was 270 negative 6. 270 negative 6. Point 270 degrees negative 6 also lies on graph, also lies on Y. Therefore, we substitute the values. For the Y value, that's negative 6, negative 6. Where do we substitute these values? On the general equation. So that will become negative 6 equals to A sine of, now the angle here is 270 degrees. So we write that 270 degrees plus Q. Let's clean it up. Therefore, negative 6 equals to A times, in brackets, 270, sine of 270 degrees, take out a calculator, sine of 270 equals to negative 1. That's what you end up with there, negative 1 plus Q. Now that gives you negative 6 equals to A times negative 1, that's negative A, plus Q. We fix that. Negative A plus Q. Negative A plus Q. And that's your equation 2. So now you've got your two equations. Let's list them. Okay, the first equation is 2 equals to A plus Q. 2 equals to A plus Q. That's your first equation. And then the second equation is negative 6 equals to minus A plus Q. Negative 6 equals to minus A plus Q. That's your equation 2. And now you go ahead and solve these simultaneous equations. Notice that you've got A and negative A on the other equation. So you use the method of elimination, which makes it so much easier. How do you do that? You simply add the 2, because once you add the 2, the A and negative A will cancel out. That's why the method of elimination is called that. 1 plus 2, equation 1 plus 2 equals to 2 equals to, okay, you will see, notice how I add them together, plus all right, negative 6 equals to A, negative A, sorry, negative A plus Q. All right. From the right hand side, we add Q plus Q, Q plus Q, that is 2Q. A plus negative A, that is A minus A, which is 0. That is 0. Two plus negative 6, that is 2 minus 6, which is negative 4. So therefore, now I've got negative 4 equals to 2Q. So we divide both sides by 2 to get rid of the 2Q. 2 on the left hand, on the right hand side, I mean. We're solving as usual here. So there's 2 cancel out. Okay, over 2, sorry. You must divide both sides by 2 Remember, what you do on the left hand side, you must also do on the right hand side. Very important. The 2's cancel out. And you're left with q. 2 goes into 2 once and into 4 twice. Therefore, on the left hand side, you're left with -2 equals to, on the right hand side, you got q. And that's your q. Now, what you do is you substitute this q into equation 1, whichever. I used equation 1 because it's the simplest. Work with the simplest. So what you do, you go therefore 2 equals to, where there is q, you put -2, a plus, in bracket, -2. And therefore, let's go to the next page. Therefore, 2 equals to, a minus 2. A minus 2. Now you take the 2's to the left hand side, so that becomes +2 equals to a. Therefore, 4 equals to a. Now you've got your a, you've got your 2. So now, therefore, a equals to, therefore, you've got your a equals to 4. Your a is equals to 4, and your q equals to -2. That's from the PS. Your q is 2 equals to -q, meaning that therefore now, remember your equation is y equals to a sine theta plus q. Your a is 4 and your q is -2. Therefore, your equation is the equation is y equals to 4 sine theta minus 2. That is the equation. We've come to the end of this video. Thank you for watching. See you in the next video. Bye.